Welcome to Jnana sinchana classes. In today's class, I would like to discuss about haloalkanes and haloarenes. Okay, haloalkanes. Haloalkanes. What are haloalkanes? See here, halo, which indicates halogen. Halogen derivatives of alkanes. Halogen derivatives of aliphatic hydrocarbons are called as haloalkanes. Halogen derivatives of aliphatic hydrocarbons. Halogen derivatives of aliphatic hydrocarbons are called as haloalkanes. Halogen derivatives of aliphatic hydrocarbons. Aliphatic hydrocarbons in the sense they contain carbon chain. Are called as haloalkanes. And next thing is haloarenes. What are haloarenes? Halogen derivatives of aromatic hydrocarbons. Halogen derivatives of aromatic hydrocarbons. That means they contain at least one benzene ring in their structure. Aromatic compounds are those in which they contain at least one benzene ring are called as aromatic hydrocarbons. Halogen derivatives of aromatic hydrocarbons are called as haloarenes. See here, these haloalkanes and haloarenes are obtained by replacing hydrogen atoms of hydrocarbons. They may be aliphatic hydrocarbons or aromatic hydrocarbons. These haloalkanes and haloarenes, they are obtained by replacing hydrogen atoms of hydrocarbons by halogen atoms. Here, halogen atoms, they are represented by the symbol X, and halogen atoms are fluorine, chlorine, bromine and iodine. See here, haloalkanes and haloarenes, they are obtained by replacing hydrogen atoms of the aliphatic hydrocarbons or aromatic hydrocarbons by halogen atoms. Generally, halogen atom is represented by the symbol X. Halogen atoms are fluorine, chlorine, bromine and iodine. Next thing is classification of haloalkanes and haloarenes. First they are classified as monohaloalkanes, monohaloarenes. They are classified as monohaloalkanes and monohaloarenes based on the number of halogen atoms present in the these haloalkanes and haloarenes. They are classified as monohaloalkanes and monohaloarenes, and dihaloalkanes and dihaloarenes. Dihaloalkanes and polyhaloalkanes and polyhaloarenes. Okay. Now I wish to give examples for these monohaloalkanes and monohaloarenes. See here, monohaloalkanes. Methane is an alkane. Here in this case, one hydrogen atom of this alkane, methane, is replaced by one halogen atom. For example, chlorine. Okay, then it becomes monohaloalkane. Chloromethane. This is methane, chloromethane are common name for this is methyl chloride. Methyl chloride. It is a monohaloalkane. Methyl chloride or chloromethane. Similarly, ethane, C2H6. Ethane is an alkane. Here, one hydrogen atom of this ethane alkane, which is replaced by one halogen atom, then it becomes monohaloalkane. With eth, two carbon atoms are there. Eth, ane, one chloroethane. The name of this compound is 1-chloroethane. Monohaloalkanes means they contain only one halogen atom. One more example. Here, this is propane. If one hydrogen atom of this propane, if it is replaced by halogen atom, that is bromine atom, here one halogen atom, then it becomes monohaloalkanes with eth prop, one bromopropane. It is an example for monohaloalkane. And next, monohaloarenes. Halogen derivatives of aromatic hydrocarbons are called as haloarenes. Monohaloarenes means here in this case they contain aromatic ring, that is benzene. Monohaloarenes, one hydrogen atom of this benzene ring, it is replaced by halogen atom. In particular, I will take chlorine halogen atom. See here, chlorobenzene. This is chlorobenzene. It is an example for monohaloarenes. Similarly, if one hydrogen atom is replaced by bromine, then it becomes bromobenzene. It is also an example for monohaloarenes. Halogen derivatives of aromatic hydrocarbons. Halogen derivatives of aromatic hydrocarbons are called as haloarenes. Monohaloarenes means one hydrogen atom of the benzene ring which is replaced by aromatic hydrocarbons which is replaced by halogen atoms, then they becomes monohaloarenes. And next one is dihaloarenes and next is second type classification, dihaloalkanes and dihaloarenes. See here in this case, two hydrogen atom of the aliphatic hydrocarbons, they are replaced by two halogen atoms, then they are called as dihaloalkanes. If two hydrogen atoms of the aromatic hydrocarbons, if they are replaced by two halogen atoms, then they become dihaloarenes. For example, dihaloalkanes. Here, this is ethane. If two hydrogen atoms, if they are replaced by two halogen atoms, I will take here chlorine atoms. Two hydrogen atoms, if they are replaced by two halogen atoms, then it becomes dihaloalkane. This is 1-1. Both the chlorine atoms are attached to first carbon atom. Okay, therefore 1,1 dichloro with eth. Eth is the root word and they contain carbon-carbon single bond. Therefore 1,1 dichloroethane. 1,1 dichloroethane. Similarly, methane. It is an alkane. alipetic hydrocarbon. If the two hydrogen atoms, if they are replaced by two halogen atoms like chlorine atoms, then it becomes dihaloalkane. This is 1,1 dichloro, 1,1 dichloro. Only one carbon atom is there. Therefore, root word is methane. Methane. Primary suffix is ane. 1,1 dichloroethane. These are the examples for dihaloalkanes. Similarly, examples for dihaloarenes. See here, this is the aromatic hydrocarbon benzene. If one hydrogen atom is replaced by halogen atoms like chlorine, then it becomes monohaloarene. If one more hydrogen atoms of the benzene ring, one more hydrogen atom of the benzene ring, if it is replaced by halogen atom, that is chlorine atom, then it becomes dihaloarene. 1, 2 dichlorobenzene. 1, 2 dichlorobenzene. It is an dihaloarene. Similarly, this is aromatic hydrocarbon. If one hydrogen atom is replaced by halogen atom like bromine, and one more hydrogen atom is replaced by halogen atom like bromine, and then it becomes 1, 2. Take this as first carbon atom, this as second carbon. The substituent group attached to the carbon atom will take the least number. 1, 2. 1, 2 dibromobenzene. 1, 2 dibromobenzene. These are example for dihaloarenes. See here, these one more important point is there here. These dihaloalkanes, they are classified into two types: vicinal halides and geminal halides. Vicinal halides and geminal halides. What are these vicinal halides and what are these geminal halides? Vicinal dihalides andrenu, geminal dihalides andrenu nodoಣ. See here, I will take some examples here. This is ethane. Okay, ethane. What is mean by vicinal dihalide? Vicinal dihalide or vicinal halide. See here, if two hydrogen atoms of the adjacent carbon atoms, two hydrogen atoms of the adjacent carbon atoms, if they are replaced by halogen atoms, if they are replaced by halogen atoms, then it becomes vicinal dihalide. The name of this compound is 1,2 dichloro. Two carbon atoms are there, therefore root word is eth, and primary suffix is, it contains carbon-carbon single bond, therefore primary suffix is ethane. Ethane. 1,2 dichloroethane. These are called as vicinal dihalides, or simply vicinal halide. Two hydrogen atoms of the adjacent carbon atoms, if they are replaced by halogen atoms, then they are called as vicinal dihalides. Example is 1,2 dichloroethane. Similarly, what are geminal halides? See here, this is ethane. This is ethane. If two hydrogen atoms of the same carbon atom, two hydrogen atoms of the same carbon atom, if they are replaced by halogen atoms, like here I will take example halogen atom as bromine. See here, if two hydrogen atoms of the same carbon atom, if they are replaced by halogen atom, then it becomes geminal halide. And the name of this one is 1,2. See here, 1,1 dibromo. There are two bromine atoms, they are attached to the same carbon atom, therefore it is geminal dihalide. 1,1 dibromo. Root word is eth. There are two carbon atoms, therefore root word is eth, and they contain carbon-carbon single bond, therefore primary suffix is primary suffix is ethane. 1,1-dibromoethane. This is about vicinal dihalide and geminal dihalide. These are very, very important for your examination. And next one is polyhaloarenes and polyhaloalkanes and polyhaloarenes. Polyhaloarenes and polyhaloalkanes and polyhaloarenes. See here, poly means they contain more than 2 halogen atoms. They contain more than 2 halogen atoms. They contain more than 2 halogen atoms. See here, for example, this is methane. Methane is an alkane. If one hydrogen atom, if it is replaced by halogen atom, then it becomes monohaloalkane. If one more hydrogen atom, if it is replaced by halogen atom, then it becomes dihaloalkane. If one more halogen atom, if it is replaced by one more hydrogen atom, if it is replaced by halogen atom, then it becomes polyhaloalkane or trihaloalkane. In the sense it contains more than 2 halogen atom, then it becomes polyhaloalkane. See here, if I will take chlorine as the halogen atom here, this is CHCl3. CHCl3. This is known as chloroform. This is common name, but the IUPAC name of this compound is here. To the first carbon atom, 3 chlorine atoms are attached. Therefore, this is 1,1,1 trichloro. Only one carbon atom is there. Therefore, 1,1 trichloromethane. 1,1 trichloromethane or simply trichloromethane. The name of this compound. It is an example for polyhaloalkane. Similarly, if one more hydrogen atom, if it is replaced by chlorine atom, then the formula of this compound is CCl4, carbon tetrachloride. Carbon tetrachloride. It is also a CCl, carbon tetrachloride. It is also an example for polyhaloalkane. The IUPAC name of this compound is 1,1,1 tetrachloro. Therefore, root word is meth and primary suffix is ane. Okay. See, tetrachloromethane. The name of this CCl4, carbon tetrachloride. And next example for polyhaloarenes. Polyhaloarenes. See here, haloarenes are these are the halogen derivatives of aromatic hydrocarbon. Aromatic hydrocarbons means benzene is an aromatic hydrocarbon. Polyhaloarenes, one hydrogen atom is replaced by one halogen atom, one more hydrogen atom, one more hydrogen atom, then it becomes trihaloarene, or it contains more than 2 halogen atom, therefore it is polyhaloarene. For example, if I take these halogen atom as bromine, then it becomes 1, 2, 3 tribromo. 1, 2, 3 tribromobenzene. Tribromobenzene. Similarly, if 3 iodine atoms are attached, if 3 hydrogen atoms of the benzene ring, if they are replaced by 3 iodine atoms, then it becomes 1, 2, 3 triiodobenzene. Triiodobenzene. This is about what? polyhaloalkanes and polyhaloarenes. Classification of mono, halo, classification of mono-halo compounds. Here, these are classified into 3 types. First one is alkyl halide, allylic halides, and benzylic halides. Benzylic halides. See here in this case, halogen atom attached to the carbon atom, halogen atom, X is halogen atom, is attached to the carbon atom, which is sp3 hybridized carbon atom. That is sp3 hybridized carbon atom. See here, again these alkyl halides, they are classified into primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. See here, what is mean by primary alkyl halide? See here, the general representation for these primary alkyl halide is halogen atom attached to the carbon atom, which is sp3 hybridized carbon atom. That means carbon contains 4 single bond is sp3 hybridized carbon atom. Halogen atom is attached to the sp3 hybridized carbon atom, and which is primary carbon atom. Which is primary carbon atom means which contain 1 alkyl group and 2 hydrogen atom. The carbon atom is said to be primary carbon atom if it contains 2 hydrogen atom and 1 alkyl group, then it is said to be primary carbon atom. See here, this is a general representation for primary alkyl halide. I will take one example for this. See here, CH3, it is an alkyl group, okay, R group. CH3, H, H, and halogen atom is bromine, okay. Then it becomes CH3, CH2, Br. CH3, CH2, Br means bromo, 1 bromo, 1 bromo, or you may write like this, CH3, CH2, Br, CH3, CH2, Br, 1 bromo. Bromine atom is attached to first carbon atom. Therefore, 1 bromo with eth. Eth is the root word, okay, and it contains carbon-carbon single bond. Therefore, primary suffix is ane. 1 bromo ethane. Similarly, one more example for this. If this halogen atom is chlorine, then it becomes 1 chloroethane. 1 chloroethane. And next example for secondary alkyl halide. What is secondary alkyl halide? See here, secondary alkyl halide means halogen atom is attached to secondary carbon atom. Alkyl halides are those in which secondary alkyl halides are those in which halogen atom is attached to the sp3 hybridized carbon atom, and this carbon atom is secondary carbon atom. Secondary carbon atom means here halogen atom attached to the carbon atom, which is sp3 hybridized carbon atom. sp3 hybridized carbon atom means it contains 4 single bond, then it becomes sp3 hybridized carbon atom. Halogen atom is attached to the sp3 hybridized carbon atom, and this is secondary carbon atom. Secondary carbon atom means it contains 2 alkyl group and only 1 hydrogen. 2 alkyl groups are attached to the carbon atom. This is known as secondary carbon atom. If halogen atom is attached to secondary carbon atom, then it is known as secondary alkyl halide. Example for this is CH3, CH3 and halogen atom is bromine. See here. You may write like this: CH3, CH, CH3, Br. Now select the carbon chain: first carbon, second carbon, third carbon. Okay. And halogen atom is attached to second carbon atom. Then it becomes, the name of this compound is 2-bromo. Substituent group is bromine. 2-bromo metheth prop. Prop is the root word. 2-bromo prop, and it contains carbon-carbon single bond. Therefore 2-bromo propane is the name of this compound. It is an example for secondary alkyl halide, and this is general representation for secondary alkyl halide. And tertiary alkyl halide means halogen atom tertiary alkyl halide means halogen atom attached to the carbon atom, and this carbon atom should be tertiary carbon atom. See here, halogen atom attached to the sp3 hybridized carbon atom. sp3 hybridized means it contains 4 single bond. Then it becomes sp3 hybridized carbon atom. Then it is said to be sp3 hybridized carbon atom. See here, halogen atom attached to the sp3 hybridized carbon atom, and this carbon atom is tertiary carbon atom. Tertiary carbon atom means it contains 3 alkyl group. It is attached to 3 alkyl group. For example for this tertiary alkyl halide is, here I will take one example here. CH3 methyl group is an alkyl group. CH3, CH3, CH3. Okay, this is the example for tertiary alkyl halide. The name of this compound is, here select the longest carbon chain: 1, 2, 3. 3 carbon atoms are there, and for second carbon atom 2 substituent groups are attached. One is chlorine and other one is methyl group. Therefore, if 2 substituent groups are there, then we have to follow alphabetical rule. See here, 2 chloro, 2 methyl, propane. 2 chloro, for second carbon atom, chlorine is attached. Therefore, 2 chloro, 2 bromo. Your IUPAC name must be a single word, and all should be small letters. 2 chloro, 2 bromo, metheth prop. Prop is the root word, and all are carbon-carbon single bond. Therefore 2 chloro, 2 bromo, propane is the name of this tertiary alkyl halide. This is about alkyl halides. They are classified as primary, secondary and tertiary. And next one is allylic halides. What are allylic halides? What are allylic halides? See here in this case, halogen atom attached to the carbon atom, halogen atom attached to the sp3 hybridized carbon atom. sp3 means it contains 4 single bonds. Then it becomes sp3 hybridized carbon atom. The carbon atom is said to be sp3 hybridized. Halogen atom attached to the sp3 hybridized carbon atom next to carbon-carbon double bond. Next to carbon-carbon double bond. Next to carbon-carbon double bond are called as allylic halide. This is the representation for allylic halide. See here, carbon-carbon double bond. After carbon-carbon double bond, carbon atom is there, to which, and this is sp3 hybridized carbon atom, and to which halogen atom is attached. Nodili, halogen atom sp3 hybridized carbon atom ಗೆ ಅಟ್ಯಾಚ್ ಆಗಬೇಕು. ಆ ಕಾರ್ಬನ್ atom ಏನಿರಬೇಕು, ನೆಕ್ಸ್ಟ್ ಟು ಕಾರ್ಬನ್-ಕಾರ್ಬನ್ ಡಬಲ್ ಬಾಂಡ್ ಇರಬೇಕು. ಅಂತ ಹ್ಯಾಲೈಡ್ಸ್ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, allylic halides ಅಂತೀವಿ. This is the representation for allylic halide. I will give one example here. CH2, Cl, CH2, CH, CH2, Cl, CH2, CH, double bond, single bond, CH to Cl. Okay, this is the example for allylic halide. Name this one. See here, we have to give first preference for the double bond. Therefore, I should name this as first carbon atom, first, second, third. Okay, then 3-chloro meth eth probe. Root word is probe, and for first carbon atom double bond is there. Therefore, 3-chloro probe 1-ene or simply propane. Probe 1-ene or simply propane. This is example for allylic halides. Next one is benzylic halides. Benzylic halides means, see here, halogen atom is attached to the sp3 hybridized carbon atom. sp3 hybridized carbon atom means it contains 4 single bonds. Halogen atom attached to the sp3 hybridized carbon atom next to benzene ring. Next to benzene ring. Okay, such halides are called as benzylic halide. I will give one example. Benzene. This is the carbon atom next to benzene. CH to C. Okay. See here, when benzene is attached in sideway, then it is considered as substituent group. Therefore, for there are 2 substituent group here. One is chlorine and one is phenyl. Then it is considered as phenyl. Okay. One is chlorine and other one is phenyl. Then the name of this compound is 1-chloro. 1-chloro, for first carbon atom chlorine is attached. 1-chloro, 1-phenyl. For first carbon atom only phenyl group is attached. 1-chloro, 1-phenyl. Only one carbon atom is there. Therefore, root word is meth. Okay, methane. 1-chloro, 1-phenyl, methane. This is about what? Benzylic halide. And next, again, these monohalo compounds, they are classified into 2 types. They are classified into 2 types as, first one is vinyl halides and benzyl halides. Vinyl halides and benzyl halides. And here in this case, halogen atom is attached to the carbon atom. Halogen atom is attached to the carbon atom, and it is sp2 hybridized carbon atom. And it is sp2 hybridized carbon atom. And it is sp2 hybridized carbon atom. See here, vinyl halides. Here in this case, see here, carbon-carbon double bond halogen atom. Okay. See here, vinylic halide. Halogen atom is attached to the carbon atom, and it is sp2 hybridized carbon atom. sp2 hybridized carbon atom means, see here, carbon atom is there and 2 hydrogen atom, double bond C H, and to which halogen atom is attached. See here, if carbon contains 1 double bond and 2 single bond, then it becomes sp2 hybridized carbon atom, CH to CHX. This is the general representation for vinyl halides, and I will give one example. CHCl. Okay. For first carbon atom, chlorine atom is there. Therefore, 1-chloro meth eth. Root word is eth, and carbon-carbon double bond is there. Therefore, 1-chloroethene. 1-chloroethene is an example for vinyl halide. And last one is benzyl halide. Benzyl halide. See here in this case, benzene contains alternate double bond and single bond. See here, this carbon atom is sp2 hybridized carbon atom, because see here, this carbon atom is sp2 hybridized because one hydrogen atom is there. Okay, this is sp2 hybridized carbon atom to which halogen atom is attached. To which halogen atom. This is general representation for benzyl halide. Okay, see here, if this halogen atom is chlorine, okay, then it becomes chlorobenzene. It is an example for benzyl halide. Similarly, bromobenzene is also example for benzyl halide. Idobenzene, this is example for benzyl halide. This is all about classification of monohalo compounds. Thanks for watching.